Hey folks, so in this video I'm going to be talking a little bit about quantum mechanics and how that might indicate how some things about quantum mechanics might one day indicate the ability to travel faster than the speed of light. This is actually a response to, at least in part, a response to a conversation I've been having on Twitter. I'm not calling it X until somebody forces me to. A conversation I've been having on Twitter. The conversation started based on the recent congressional hearings with the Grush guy and some of the people talking about whether the United States has alien craft and whatnot. And we got into a discussion of quantum physics. And I asked, as I often do, when somebody says, hey, you'll never be able to travel faster than the speed of light, it's not possible, and aliens from far, far away can't possibly be visiting here because space is too great, I will ask about quantum physics. Specifically, I like to talk about quantum entanglement. And usually when I say that, people just stop talking. But this one individual, Tamara Kane, at Tamara Monkey, did try to engage me on this subject, which I appreciate, and that is why I am officially responding to it. Now, and I mean no offense in this, she did kind of go out in left field based on what I was talking about. She started talking about whether an alien could be quantum entangled with his spaceship, which wouldn't actually mean faster than light travel. So I wanted to talk about what it is about specifically quantum entanglement that makes me think we can't close the book on the idea of faster than light travel. So, to sort of explain how quantum entanglement works, briefly, for anybody who doesn't already know, if you have two very light subatomic particles, we'll say electrons. Two electrons are created at the same time in the same place. They will become, or at least they may become, quantum entangled. And what that means is, if you change one of them, let's say you change how it's oriented. You rotate it this way. This one will rotate in exactly the same way at the same time, simultaneously. And it can happen with either one. So if you change this one will change. And if you change this one will change. The two are entangled. And it happens not just with physical orientation, but also like this is a Halls here, by the way. It's a Halls cough drop. I keep these on my desk because I teach some classes and my throat gets very dry. These can be a lifesaver. So if I put this Halls in my mouth and I eat it and it melts, this one melts too. Or if I put this one in my mouth, this one will melt too. Even though there's nothing directly melting it, it still melts because they're quantum entangled. Now, I can take one of these cough drops, one of these electrons, and I can put it in another room. I can take another state. I can put it on a rocket ship and send it to Mars or to the Andromeda galaxy, and no matter how far away it is, that entanglement will continue. If you turn one of them, the other one automatically turns too. And it's instantaneous. Now, there is a reason this is important, and it is that instantaneousness. Now, the way it was originally thought of, and Einstein actually thought of it this way and kind of described it this way, is like there's some sort of communication, some energy that must be traveling between the two things, and because it happens instantaneously, so far away, that must mean that that energy, that communication, is traveling faster than the relativistic speed limit of the speed of light. Theory of relativity says nothing ever travels faster than the speed of light. Well, if quantum entanglement is happening through some sort of communication, which is the original thought, then that communication, that energy, is traveling faster than the speed of light. So there's some kind of exception to that speed limit. Now, we don't know how that exception happens. We don't know what the communication would be, or the energy, or whatever. We don't know what causes this. So if it is communication, we don't know what it is, or how it's traveling faster than the speed of light, or what the exception is. But will we learn in the future? Will this be useful? Who knows? There's another possible explanation, though. And I think this one is even more interesting. And that is that these two electrons, these two Halls may not actually be two Halls. They may not be two electrons. It may be one electron which exists in two locations at the same time. Now, this is not one electron and one reflection. It's not like you're seeing the electron in a mirror, because either one can affect the other. It would be one electron in two places. Now, that's hard to understand because in our world, one thing doesn't exist in two places at the same time. It can exist in two places sequentially. First it's in one place and then it's another, or you can see a reflection, but the idea that this one thing exists fully in two places is just kind of crazy. But at the subatomic level, that may be the case. If that's true, well, if a subatomic particle, which has mass, an electron has mass, if a subatomic particle containing mass can exist in two places in space at the same time, can you make that happen sequentially? Can you start here, and instead of having to go over here, can you teleport? Can you make it be, instead of they both exist, to this exists, and this exists? If you could teleport or skip through space, if we understood, and if this is actually what's happening, if there's one atom, or not one atom, but one electron existing in two places, if we can scale that up to where large chemically compound things can do that, if you can skip through space, then you can travel faster than the speed of light without actually traveling faster than the speed of light. You're not violating any speed limits because you're not going like this. You're here, and then you're here. Who knows? There are also some other possible explanations, including like if we live in a hologram, or a lot of these a little bit more far out examples. But I think because we don't know how this happens, and it means most likely either you have something traveling faster than the speed of light, or you have a thing with mass existing completely and wholly in two places at the same time. I think it's far too early to rule out the possibility that one day we will develop faster than light travel, or that some other civilization out there in the cosmos may already have done it. I think it's about like, for the thousands of years before the invention of an airplane, when people said, hey, humans will never fly. You'll never go faster than a train, or you'll never go faster than you can riding a horse, or you'll never go faster than you can walk. Well, under the understanding and technology of those people, it was true, but in the long-term sense of things, it wasn't, because now people fly all the time. So anyway, that's my response, and thank you for watching.